Hello, dear friends. Is everything good? I would like to present to your attention my work that I've been doing almost every day of my life. It's about technical intelligence systems. But first I'd like to say a few words about the organization I represent. That's Trapeznikov Control Problem Institute of the Russian Academy of Science. We were doing AI when even the term was not yet coined. So all the areas of research related to control are worked on in the Institute, and the goal or the theme that brings us all together is robot technology. Of course, we are interested in basic science, but we don't shirk from applied aspects. Also about myself, I am a chief research scientist at the Institute of Control Problems, responsible for intelligence robotechnic systems. I'm also a member of the Scientific Council, and I'm also chairman of the Russian National Committee of RoboCap. That's one of the best-known contests in robot technology worldwide. And of course, I have to come back to the basic principles that were formulated quite a long time ago by Karel Čapek, who gave the first definition of robot technology. And as we remember, almost all sci-fi writers implied that any technology system was to think somehow, provide its own existence, and could perform some actions. And of course, they first focused on some mechanical operation, and that was the continuation of the idea of indentured labor. But then the cognition and decision-making agency was being added, based on which Isaac Asimov formulated his three laws of robot technology that are now being extended to the sphere of artificial intelligence. And of course, we can't help making parallels, and the basic concept of AI, a basic definition shown in this slide, forms a holistic picture that we need to embed somehow in robots. I would also like to say that artificial intelligence is not the same thing that artificial intellect. Of course, it may be a problem of translation, but nevertheless, the definition was introduced by John McCarthy in 1956, and it just so happened that people took quite a long time to work that through. And Alan Turing published his book and Machine Think in 1936. All of you know about the Turing test, and also the work that have been done since a long time during formal machine. So, of course, the diversity of robot technology is very broad. Here we have different cases from different line of application. First, manipulator hands are shown on the left. Robotic hands that appeared first are shown on the left. On the left, remembering history, so the Soviet Union was one of the largest countries in terms of the number of robots in production. Also, a robot like that is also used in space. We have a satellite, a robot like that, yes, and it uses the basics of AI. It's a lunar vehicle and other terrestrial devices. Following the time hand and a clock hand, we see such things used in blames, in drones, and where you can provide AI that determines the intelligent behavior of these systems. Water environment offers a great diversity because the delays that we have to deal with there, together with the energy aspect, which is a weak point of flying drones. But in water, there are whole application areas where AI systems can be used. It's about self-navigating boats or torpedoes, whatever. Then we have a separate class of moving robots, either a robot dog or maybe such technology as you see at the bottom left, but also exoskeletons that a worker can put on to carry weights. And there are both active and passive devices like that. Passive are those that redistribute load, allowing a person to relax. And perhaps the best known types of robot are anthropomorphic robots. That is, robots created following the human structure as a pattern. But here, I would like to say that robots are more power-intensive than a human. From history, we know that the people learned to fly exactly at the time when they gave up on the idea of, using the wings. Just like for terrestrial vehicles, people started using wheels, even though in nature you won't have this structure. But we have to understand that even though biomorphic elements allow us to develop and try to figure out how it happens in live nature, whether how a person thinks or how you combine different technology aspects, you still have to understand that the methods are also maybe effective. The school of thought that is developed in Volgograd University shows predictive analytics. This slide shows this evolution regarding what and how we use in robot technology. We analyze what has done. For instance, the robot has driven on a path in a territory, on its way to identify what's there, how it's there, why it's there. In terms of predictive analytics, it can find an answer to the question of why. For instance, why the soil here was wet yesterday and today it just turned into stone. And then you need to include not just the simple analytics elements, but machine learning elements, such as predictive analytics. Again, we're saying here that here we exist and work in the area, well, like for instance terrestrial robot technology. We've made this decision, but in order to teach a robot not to bump into walls, what do we need to do? We need to run several experiments where it would indeed crash into the wall. For this, we have a digital twin that allows, in the virtual world, simulate indefinite number of collisions against the wall, and your measures to handle that. Then prospective analytics allows us to predict what's going to happen ahead. A couple of examples. Let's see how we used to have it. Historically, the robot technology that was either poising to do that, use the robot of chess. But at the same time, in 1974, the world's first computer program of a machine that won all the rest was developed in our institute, and its name was Kaisa. And if you see, in 1997, Deep Blue won ultimately, because it could predict and calculate several moves ahead. They said we have quite a lot of open games like StarCraft, even though StarCraft has been supported for the past 2 months. Nevertheless, all these elements in prediction, forecasting, and analytics do exist, even though you don't have a full map, but only partly available. This way, AlphaStar can improve on human interaction. So it's yet much early to say that we have achieved the strong AI or super AI. Here we have to talk about analytics. First of all, it's about interaction with humans. It's artificial hands, limbs, arms. This allows us to predict and formalize how a person wants to behave. And here, the bottom picture here is about managing brain signals. The interaction between robots and humans that allow us to go to a new level. And of course, I can't help noticing how these prognostic models are implemented in life, how's going to happen in real life. Well, production is production, but you need to perfect the algorithms. And in particular, we've got such well-known competitions, as you can see here, robot soccer. Here you see different elements, simulation games, robots that look like a fantastical feature are also done by the machine. And and there's a capability of running 3 or 4 codes to play with a transparent ball. Last year, I played with such robots. Of course, we won 4-1 against them. But I think that by the year 2050, as RoboCap wants, it'll be about playing between people and robots. And of course, there are robots that include elements of AI that are needed to make solutions at different stages in their phase cycle, both in the industry, top right-hand corner, breakdowns. You have a wheel robot here, also for home conditions. And in conclusion, I'd like to say a few words. We are creating the future, and the future starts today. Those who listen to me are perhaps the ones who are going to keep active tomorrow. So if we remember the history, digitization and cyberization are certain things that have come to life. And now we're going to talk about artificial advent of such technologies into our lives. However much I'd like to talk to a person, if I'm to get something from the bank, it always substitutes a person, substitutes a robot for a person. This includes integration of people and IA. I'm referring to the so-called biohackers. So that's our fate. Thank you very much, all of you. I wish you a good day, and I'm hoping that we'll be able to create real future where a person will be the critical component, and as your president said, they would still have the conscious capacity.
Thank you, Roman. It was really interesting. I've learned a lot of new things. May I suggest that I ask a couple of questions? I think we are not so well aware about robot making in Russia rather than other countries. What about Russia's position in terms of robot making? I'm talking about those robots that are AI conscious. We have state-of-the-art solutions that are ahead of some of the international ones. For example, in the Far East, in St. Petersburg, in Vladivostok, they are beyond average international ones. Just in August, we conducted some competition with robots, and they introduced the solutions that are just in the inception stage or design stage abroad. And some of the solutions were even better than teams from Iran. As far as the anthropomorphic resemblance, why should we have it in the first place? Each of the robots is dedicated to resolve particular tasks. I mean, to operate underwater is one of the tasks, and we have real good solutions about rescue robots. In Fukushima, for instance, it was the Russian robot that did not malfunction immediately, unlike that Italian robot, for instance, and those friends of ours who have moved from Japan to Russia. They are specializing in building rescue robots. Unfortunately, the robot industry as such is not so well developed, but specific solutions for Ministry of Interior and Ministry of Emergencies are beyond the average international level. That's for sure.